And then we'll get going. All right, we are live. Excellent. Let me bring up the chat on my phone so that I have it for when I walk over to that desk. That would be wonderful. I gave my first senior exam today. That was fun. Things are moving. It's like we are literally in the home stretch of everything. Okay, number one, we are reviewing today and Wednesday, reviewing that final exam packet in preparation for the exam that we're going to take on Friday. When you come in on Friday, you need to make sure that you have that Chromebook ready to go because your exam, of course, will be on Linkit. So please make sure you're aware of that. I will have a live stream on Friday, regardless for those who are online, even though I'm not teaching anything, because I just need to make sure you get those instructions and the code, and I can answer any questions. And then once you're in the exam, it's just you're good to go until the end, 12/22. In an attempt to give everyone a second chance at a minor, I did this in the third marking period, and I'm going to do it again in this marking period. Before I leave here today, I am going to assign a second chance minor that would replace your lowest minor grade for the marking period. Okay, so please keep that in mind. Today, before I leave here today, I'm going to assign a second chance minor, which would replace the lowest recorded grade for the lowest recorded minor assessment grade, be clear, for the fourth marking period. So it's voluntary or optional, whatever. If you don't take the second chance thing, nothing hurts you. But if you take it and you score well, it could only help you. So please make sure you are aware of that. For those of you that are in the live stream right now, if you would be so kind to leave a comment, that'd be wonderful for my attendance purposes. In a moment, I'm going to walk over and we're going to continue working through that final exam packet that I posted on Google Classroom last Thursday. We're going to continue doing that. Like I said, we're taking our exam on Friday. And then next week, I have you in this classroom again on Thursday, the 17th. Seniors would be excused that day. I'm still taking a regular attendance that day, so please make sure you're aware of that. So yes, I do see the 3 comments that have been left so far. I'm assuming that there are going to be more that are going to pop up in the next few moments. But if you would, I'm going to continue working on this final exam review. Write down what you need to write down as we move ahead with this. I gotta open that thing and that thing. And there it goes. Now, in terms of this final exam review, I'm just gonna go through it a question at a time. I'm just gonna try to knock out as much as humanly possible. I'm gonna tell you what questions that you can generally just be like, you can skip those for the most part if need be. But I want to make sure that you are as prepared as possible for these questions. See, I'll bring this up. There we go. We left off, I believe. There we go. I believe we left off. We finished up number 8 last time, I want to say. So we'll start with number 9 if need be. Now, again, in your Google Classroom live stream, the post from last Thursday, right here, the post from last Thursday has that final exam review. So if you need to see what these questions are saying, by all means, make sure you're checking that final exam PDF or final exam review PDF as we go through these questions one at a time. So let me flip a screen so you can see what I am writing. This is just the final exam review continued. And we will do such as that. Today is the 7th. There we go. Good. And I'm picking up with number 9. Now, number 9, I'm actually just going to copy it down and copy down the image that they give you, just so I can talk about this a little bit in terms of a parabola. And you'll see exactly what I'm drawing in just one moment. There we go. But the question wants to know, what line is the graph symmetrical around? What is the graph symmetrical about? I tried copying this down as best as I could right here. This is number 9. Number 9, the only pieces of information that they give you is the fact that it's a parabola and it crosses the x-axis twice. It crosses the x-axis at 1 and it crosses the x-axis at 5. They give you nothing else. They don't give you an equation. They give you nothing. But every single parabola is symmetrical around its vertex. That is a vertical line that parabola is symmetrical around. You could fold that piece of paper on that dotted line and the parabola should line up with itself if it is indeed reflective around that line, which it is. That line is at the value of x equals 3. That is the vertical line. That is the equation of the line that the graph is symmetrical around. That's all they really wanted to know for that particular question. I'm assuming that on the actual Linkit exam, it'll either be one of those things where you just click which one applies, multiple choice. I'm assuming that's just as simple. But if they do have you actually typing in the equation, that is the equation that they would want, the full equation. Number 10. Number 10, I'm going to copy it down, but number 10, I'll read the instructions first. They want you to write an equivalent expression to the following equation. I've seen them do stuff like this where they're just like, write an equivalent expression. I've seen them do questions like this on Edge Elastic. Write an equivalent expression. There are technically, in my opinion, 2 answers that they would generally accept. 2 specific answers that they could accept for equivalent expressions. But the hint that they give you on number 10, is to factor. How far can I zoom in on this? Not too bad. Okay. The hint that they give you is to factor. So that's exactly what I'm going to do. First, you need to look for a greatest common factor, which at this point you'd be like, well, they can all be divided by 2. Yes, they can. They can all be divided by 2. That right there, what I have written there is technically, by definition, an equivalent expression. That could be accepted as an answer. I would accept that as an answer for an equivalent expression. But this thing is probably programmed for you to go a little bit farther. It is probably programmed for you to factor this thing completely. So that's exactly what I'm about to do, if indeed it is factorable. If I were to look at what is inside of the parentheses and attempt to factor that thing, I'd begin that Tucker method process by finding A times C. I'd find my 2 magic numbers, which have to multiply to -21 and add up to +4, which in this case would be +7 and -3. I'd organize that junk into a T. In the top of the T chart, where I'm pointing, it is a 3x squared. So in the top of that T chart, as always, I'm going to have to put a 3x and a 3x. 3 over -3 reduces down to 1 over -1. So vertically, I would have 3x plus 7 and a 1x minus 1. But now here's the trick to the whole thing. And I say trick because I want to make sure that you don't fall into this trap on Linkit when you take the final exam. If you were to just write these 2 factors, Linkit would mark it wrong, and Linkit would be justified. If you want to get full credit, you would have to bring down that greatest common factor of 2. And once you bring down that greatest common factor of 2, now Linkit will mark it correct. If you take out a greatest common factor, you need to include it as a factor in your answer. Please be aware of that. Linkit is not for a lot of these questions. It is not. So take your time with them, see what you can do with them. Let's see. Oh, number 11. Okay. Number 11, and I'm going to have to write this down, so I'm going to leave it up on the board for a moment. But number 11 is basically asking you to divide those two expressions. They want you to take 4x to the 4th minus 21x cubed minus 46x squared plus 219x plus 180, and they want you to divide it by x plus 4. That's what they want you to do. They're saying, let the first equation be that big, long monstrosity. What is the remainder when you divide it by x plus 4? Here's the actual question right here. Here's the actual question. That's what I wrote down from the problem. This is number 11. They want to know, okay, if you divided these, what is the remainder? Would it divide evenly, meaning that the remainder would be 0, or would there be something left over? All we want to know is, what is that remainder? The easiest, simplest, most straightforward way to do this problem is the synthetic bar. This is the fastest way to do this problem. Inside the synthetic bar, we talked about this last week. Inside the synthetic bar, I'm going to write the coefficients in order from largest exponent to smallest exponent. Be careful of the negative signs. It's a negative 21 and a negative 46. But then I'm dividing it by x plus 4. And in this spot, I would need the 0 of x plus 4. The quote unquote 0 of the expression x plus 4. In this case, I am going to be putting in a negative 4 in that spot. If you take x plus 4 and you set it equal to 0 and solve, it would produce a negative 4. That is what goes on the outside of that bar. Now, again, the question, all that the question wants is, what is my remainder? And the remainder will end up being, and I'm going to point my marker right there at it, the remainder will end up being right there in that spot where my pen is pointing. Whatever number ends up being in that spot, that is the answer to this particular question. They don't want anything else other than the remainder. Well, synthetic division is nothing more than adding and multiplying. 4 plus nothing just comes straight down. Multiply against the negative 4. Add straight up and down. I'm going to have to go to a calculator for the rest of this one. Multiply negative 37 times negative 4. Oh, snap. I get 148. And it's positive, so no big deal there. There we go. I'm going to have to, I have to add those two, so I get what? Positive 102. That's really weird. These numbers are going to get out of hand fairly quickly. If I multiply 2 by negative 4, I get negative 408. Ugh. I don't like this, but this is exactly what it should do. Negative 408 times negative 4. Gross. Gives me 1632. That is really weird. These numbers are really getting out of hand fairly quickly. Let me double check the math here. 4, negative 16, negative 21 and negative 16 give me negative 37, times negative 4 gives me positive 148, plus negative 46 gives me positive 102. Yeah, this should go away. This 1632 is off. I'll fix that in a moment. But negative 4 times 102 gives me negative 408. Negative 408 plus 219, there we go, gives me negative 189. That number should go there. I knew the numbers were getting out of hand. I just wanted to make sure that they were correct. Multiply that by negative 4, you get, oh, gross, 756. And then if you add vertically, you get the number 936. As terrible, as horrible as that number is, that is my answer to this question. You add straight up and down. You always multiply by the number on the outside. That is how we would knock out synthetic division. And then whatever number ends up on the bottom right, that is our remainder. Ugh, such a gross problem. But that is the answer. That is what they wanted for number 11. Okay, number 12. Number 12 is asking about inverses. Number 12 basically says, and I'm going to copy this down as I see it, f of x equals this weird looking fraction. And they want you to find the inverse function. So this is what I wrote down. This is what I wrote down for number 12. They say, here's a function, f of x. Find the inverse. That's what that symbolage means right here. F to the negative first means the inverse function. That's what they want. That's what they're actually telling you to find. When we did inverses back in chapter, goodness gracious, chapter 6, I believe it was. When we did inverses back in chapter 6, inverses are where everything flips across the line y equals x. Every single ordered pair, x comma y, becomes y comma x in the inverse. Inverse functions basically undo each other. They undo each other. They cancel each other out for the most part. That's what they do. That's what they're supposed to do. They want you to find the inverse function of this weird-looking fraction. Here is the absolute most straightforward way to get it done. First, I'm going to do y equals instead of f of x equals. It makes me feel a lot better to do y equals. 1,000 times better to do y equals. Every inverse is flipped across the line y equals x. Every single x comma y ordered pair becomes y comma x in the inverse. So my next step is to literally switch the positions of x and y. I am literally switching the positions of x and y. That's what it's supposed to do. It's really weird, but that's what I need. Absolutely. Now, from here, I just have to get y by itself. I just have to get y by itself because now I have a brand new function. Technically, I have an inverse function. I have performed the inverse step by literally switching the positions of x and y. I have switched their positions. But now I got to solve for y. So I'm going to multiply both sides by 5. I think the easiest way to go about this, I'm going to add y because it's a negative y and I want it to be a positive y, I'm going to add y and I'm going to subtract 5x. So I'm going to add y to both sides. I'm going to subtract 5x from both sides. Just moving things around where these cancel and these cancel, leaving me with y equals negative 5x plus 4. Literally, that's the answer. That's what they wanted. I'm going to change that y to the notation that they like, although it is perfectly acceptable to leave it as y equals. Perfectly acceptable. But some people do prefer writing that inverse notation. When I say some people, I mean like some teachers and professors and link-it programmers. They prefer that notation. These two functions are inverses of one another, the original one that they gave us and this final equation at the bottom. You switch x and y, and you solve for y. So literally, those are the two steps that have to take place. Right here, you switch x and y, and you solve for y. Those are the only two steps that have to take place. And once you do that, you have the inverse function. That's number 12. Oh, what is this? Okay, good. Number 13. Number 13, I'm not even going to write down. Number 13, I am not going to write down, simply because number 13 is, it's one of those statistics problems that is closer to logic / common sense. Let me just talk briefly about what number 13 entails. Number 13 is trying to conduct a survey about sports. They're going to call a number of households in one city to question them about their favorite sports. Okay. How should the company conduct the survey in order to have an accurate collection of survey responses relating to the preferences of the general population of the city? The problem is that they're only surveying one city. And if you live in a city that has certain sports teams, then perhaps the city might be biased towards a certain sport. For example, if you were to call up, I don't know, I'm trying to think of like a city that only has certain sports in it. I don't know. Okay, I'll use Oklahoma. If you were to call up people in Oklahoma City and ask them what their favorite sport was, I mean, if they like professional sports, perhaps they would just say basketball because Oklahoma City has a basketball team. If you were talking, other sports, I mean, Oklahoma probably likes football a bit more too. But depending on the city that you call, they might like one sport over the other. If you call a city in Canada, they're probably going to like hockey. How should the company conduct the survey? They need to have a random sample. That's basically what it comes down to. They need to have a random sample. Don't limit it to just one city. If you have a random sample of multiple cities, then you'll actually have a better way of going about this process. But again, number 13 is just one of those problems that I'd rather just skip. But it is more logic, common sense based. Let's talk number 14. Write this information down. Number 14 is talking about a geometric sequence. And the only two pieces of information that they give you are the following. Flip my camera. Cha-chow. There it is. Number 14 only gives you these pieces of information. The first term, how to find the next term, and then the question that they ask is, what is the fourth term? Honestly, this question should be a gimme. Should be. But it's one of those things where if you just kind of skim through it and just rush through the problem just to get it done, you're just going to stumble. If you look at that equation that they give you, they're basically saying you want to find the nth term, take the previous term and multiply it by 2. That's what they're really saying. Take the previous term and multiply it by 2. So literally it's like, 4 times 2, 8 times 2, 32 times 2. There we go, done. That problem should literally, if you interpret it correctly, it should take you like 8 seconds. If you interpret it correctly. What was the what? Yeah. Times 2. You beat me. I totally skipped over and ran into a wall. I'm going to put a sad face here. And I'm going to say, there's a speaking bubble. Justin wins. There we go. Oh, you can't see it. Oh, there it is. He wins. Why did I think that was doubled? Mind you, it is doubled. I'm sorry. Why did I think double of 8 was 32? Where's my head there? You know what I think I did? I said the words doubled, but then in my head, I did the calculation of multiplying these two together. I think I did. I don't really know, but then I took 32 and I doubled it correctly, though. What the heck? Gosh. Let me find, where is it? There we go. I'll fix it right here. 1632. There we go. That's better. Now, I wish I could say I planned that. I totally did not. You know, teachers try to play that off like, oh yeah, I planned that. Like, no, I totally didn't. That was just a mistake. But it does show a good example of like, if you're just kind of skimming through the problem and just kind of going through the paces, how a simple mistake could cost you points. That cost me points. I want my points back, Justin. But yeah, that's literally all you have to do there. Number 15, I'm not even going to write down, but I will talk about it. They basically say 80 students were asked, what is your favorite color? The frequency table shows the results. One person chosen at random is a boy. If favorite color is independent of gender, what is the probability that his favorite color would be green? It's just literally, 10 out of 38. Like, I'm not even going to write that down, but there are 10 boys who like green out of 38 total boys. Done. I don't even know why that question is on here. The Algebra 2 teachers made these things together. So there are some questions that some put on and some questions that other put on, but it's just like, why would this even be on here? It's just messed up. 10 out of 38. Now they would say, what is the probability? So if you're going to do 10 out of 38, you're better off. Here it is. You're better off actually putting this percentage right here, 26.3%. But it's 10 out of 38. It depends on how Lincoln decides to ask for the answers. They may ask for the fraction, for the reduced fraction, or they may ask for the actual decimal. So keep that in mind. But it's like, oh yeah, boys chosen at random. Of the boys, what's the probability that his favorite color would be green? Well, the 38 boys, 10 out of 38. It's really weird. Okay, now this one. I'm actually going to go up to the board for this one. For number 16. There we go. I want to go up to the board because I want to draw stuff directly on this graph. There it is. Okay. Be very careful with these kinds of questions. A ball is thrown up in the air. The graph below shows the height of the ball in feet with respect to time in seconds. All right. How long is the ball in the air? Well, this is when the ball started. This is when the ball landed. The ball was in the air about, again, you're going to have to estimate because it's like between a couple of numbers, but it's like about 4.2 seconds. Yeah, about 4.2 seconds. 4.2, 4.25, either number would be acceptable. Yeah, they don't really give you an exact number. They don't even give you an equation. It's just a matter of identifying, okay, about 4.2 seconds. There we go. At what time is the ball 40 feet in the air? Well, the ball is in the air at 40 feet at two separate locations, here and here. It hits 40 feet on the way up, and it hits 40 feet on the way down. It hits 40 feet on the way up. Again, you're going to have to estimate that. About 0.75, 0.7, something along those lines. Again, an approximate estimate would be appropriate and it'd be acceptable. And this one about 3.6. Yeah, so I'm going to go, actually, yeah, I'll probably go with 0.6 here. So I'll do like 0.6 and 3.6 seconds. Those are pure approximations because I have to eyeball that thing. There's no equation that they gave me. It's just understanding how the graph is actually displaying this data. If you put like 0.7 and 3.7, that's also perfectly acceptable. What is the maximum height that the ball reaches? This would be whatever this is up here, whatever the vertex is. And again, I'm just estimating what this thing actually is. Yeah. As best I can, just kind of. Oh, that was terrible. There we go. It's over 70. 75 feet? Yeah, about 75 feet, give or take. It's definitely more than 70, but clearly less than 80. So about 75 feet. That's the best that you can do to estimate what that thing is supposed to be. Yeah, 75 feet. There we go. Now, the question for part D, that does take a little bit of an explanation. And this explanation would be read and graded. Does it take the ball the same amount of time to go up as it takes to come back down? The answer is no. The answer is no. But why is the real question? Why? Does it take the ball the same amount of time to go up as it takes to come down? No, it doesn't. The reason? Because the ball does not start 0 feet above the ground. The ball actually starts, I don't know exactly how much. I'm going to estimate about 5, but it starts about 5 feet off the ground. And because of that, it takes a certain amount of time to go up, hit that maximum, come back down, and return to about 5 feet off the ground. But then it takes an extra fraction of a second to hit the ground. Because of that extra fraction of a second, it actually takes a little bit longer for that ball to come down versus the amount of time it spent going up. Does it take the same amount of time? No, because it did not start going up from 0 feet. It started going up, again, approximately about 5 feet. That would be an acceptable interpretation of this problem. Interpreting graphs of parabolas. Yes, they are symmetric, but the starting location was just a bit off. Let's see. Oh my gosh. I said this to my class on Friday. And I'll say the same exact thing to you guys. This question right here, number 17, annoys me. Annoys me to all heck. Because It's such a ridiculous question. Number 17 is just, it's, let me read it. The table below shows the distance in miles that Jody is away from home at given times throughout the day. Write a possible scenario to describe what this graph tells us about Jody's day. Basically, it's like, and I've seen these questions in Algebra 1, and I've seen these questions in pre-algebra. It's like, tell a story about Jody's day based on this graph. This question annoys me. Tell a story. Write a possible scenario about Jody's day. I don't like it. I mean, it's fairly straightforward. I'm not a fan of these types of questions. Okay, at 9 a.m., she was 4 miles away from home. From 10 a.m. to 11 a.m., she was 7 miles away from home. And then at noon, she was 4 miles away. And then at 1 o'clock, she was 0 miles away. So literally, you could just be like, okay, Jody was traveling to work at 9 a.m. She got to work at 10 a.m. At 11 a.m., she was still there, still 7 miles away from home. Around noon, she started coming home. And then at 1 o'clock, she made it and she walked in the front door. Okay. I really don't like these questions. I'm not a fan of them, but what else are you going to do? You just got to write a quick sentence about it and then move on from there. All right. 18. I was so excited when I saw 18 on Friday. I was so excited when I saw this equation on Friday with my period 3B class. I was like, yes, finally, a math problem that we can dig our hands into, a math problem that's going to allow us to factor it apart and find all of its zeros. And then I actually, we did it, and it was barely anything. I was very disappointed by this problem. Let me show you what I mean. I took this equation and I typed it into my y equals key in the calculator. Because when you look at a problem like number 18, that is the first thing that you should try to do. Type it into the y equals key to get an idea as to what it looks like. And then based on what it looks like, you can try to break this thing apart and try to find some of the components of it, the zeros, the shapes, the turns, all that wonderful stuff. And I typed this whole thing in, and then I graphed it. And it gave me this. And I was very disappointed. So here are your instructions. If the problem wants you to graph something like this, yes, type it into the y equals key. Or if you want to use Desmos, because you guys are going to be on Linkit on Friday. So if you're on Linkit, you could easily use Desmos as well. Desmos, I don't know, might be a bit more straightforward. Let me actually bring up Desmos right here. Graphing calculator. You do f of x equals x to the fourth. I should bring it up here. There we go. Plus 2x to the third minus 5x plus 1. It's like, yay, there it is. Cool. Woo. But like I said, in reality, all you really need is to hit second graph to get that table of values. Find me that table of values. Copy down some of those ordered pairs. Draw an accurate representation of the graph. And you should be golden. That's all they really want. They just want some accuracy. So if you need to get that accuracy, type it into your y equals key, second graph, and you have that graphing calculator on your Chromebook. You do. But second graph, you get that table of values, and then based on all of that information, you can copy down an accurate graph. And then answer whatever questions they want. Well, how many zeros does this thing have? Oh, well, it has 2 because it crosses the x-axis twice. Cool. They wouldn't, How many turning points does it have? Well, it only has 1 visible turning point. Okay. They wouldn't, I don't know. This question really, all it asked you on Where is it? Oh, it's right here. There we go. This question literally just said, hey, graph this. Okay, I'll graph it. That's why I was disappointed. Number 19. Circle graph. Oh my goodness, this is just a ridiculous question. Does the circle graph below correctly represent the number of students in these groups? Why or why not? No, it does not. Why? Because circle graphs, otherwise known as pie charts, should add up to 100%. Okay. Like literally, that's a... I don't even know what the point of the... Well, I know what the point of this problem is, but it's just such a weird problem. It doesn't... But anyway, yeah, that's the problem that it is. Here's what I'm going to do. We're going to do one more problem right now. One more problem right now. And then we will save the rest for Wednesday, because we're going to enter the intervention period of this class. We'll do one more problem together, and then I will tell you what you can work on in regards to this intervention period, because there are several things that you could potentially work on. But I'm going to take number 20. We're going to do this one together. I'm going to take it a little bit farther than what the question's asking. Yeah. And then you guys are going to do that intervention period. So here's number 20. Number 20, the directions, all the directions ask are, hey, what are the next 3 terms? I'm going to take it a little bit farther than that. Like, what are the next 3 terms? Well, it looks like it's adding 0.02 each time. So the next 3 terms should be like 0.11, 0.13, and 0.15. And I would say yes. Yes, they are. Yay, we did it. But I'm going to take it a little farther. I'm going to take this one just a little bit farther. Those 3 numbers would answer the question. Absolutely, yes, they would. But what if the question asked for a general rule? A general rule cannot just be add 0.02 each time. No. A general rule needs to be an equation that allows you to get any term you want at any given moment. Yes, the common difference is 0.02, but that's only part of the problem. Your first term is 0.03, and your general rule for an arithmetic sequence should look like this. Put a little arrow there. There we go. Where you can now plug in the first term and the common difference, and all you would have to worry about is simplifying. 0.03 plus 0.02n minus 0.02, 0.02n plus 0.01. That is my general rule for this particular problem. That general rule would allow you to find any term in the sequence. Any. Doesn't matter what it is. Find the 100th, the billionth, the trillionth. You don't have to keep adding 0.02. You just plug in the proper number to get that term. Now, what is in store for you guys today? First, you do have a quizzes due on, I believe the due date was Wednesday. Yes, it is. I posted it last week. It is due on the 9th. You have a quizzes. It looks like, from what I can see, looks like 4 people have already completed it. You get 3 attempts. 3 attempts to get that particular quizzes done. I strongly urge you, if you do not get the score that you would like, utilize those 3 attempts. I'm looking at the actual quizzes page right now. I can see most people are using at least 2 of the attempts. I can see that. Yep. Oh, that kid used all 3. Nice. Okay. But you do have a quizzes due for me on Wednesday. I strongly suggest that if you did not do that quizzes, that you utilize this time to get it done. If the quizzes is complete, or you do one attempt and you plan on doing the rest later, I strongly suggest that you use this time to get something else done. Do you owe me an Edge Elastic major? Well, the Edge Elastic major is still open. Do you owe me one of the post assessments on Linkit? Those links are still live. You can still get them done. Now, like I said, I am going to be posting a makeup assessment that is free to take. And if you score better than your lowest minor, I will replace the grade. That is my end of marking period gift, like I did last marking period. But I will be posting that later today, before you leave the building, probably. So you have your task in front of you. You have until 12:22. You have approximately 30 minutes. Either work on the quizzes that's due tomorrow. Due Wednesday. Or make up some of the things that you owe me that are missing. Let's get them done. Let's bring those grades up. For those of you in the live chat, I'm going to keep the chat open in case you have any questions. I will have the live chat open up at my desk over here. If you have not left a comment, please make sure that you do so, because I need to take that accurate attendance. E. E. Yeah, it's right down there. right. Like I said, that quizzes is due on Wednesday. I will be posting a makeup assessment that is optional that will replace the lowest minor grade for the marking period. On Wednesday, we will finish up reviewing whatever we need to review. And then on Friday, we will be knocking out the final exam. If you have not left a comment in the chat, please make sure that you do so, that I can take proper attendance. And the bell's going to ring in approximately 7 seconds. So we'll see you then.